Hey everyone, this is going to be Algebra 1 homework from Unit 8, lesson number 3. It's called the shifted form of a parabola. So this is the homework. Hopefully this is a help. Hopefully everyone's doing all right. So either work along with me or check your answers. Alright, so it talks about how this is showing y equals x squared. We want to draw these quadratic functions. And it says try to do these without using your calculator. Obviously you can if you wanted to. In testing or real life, you'd probably use your calculator. But just let's bear with this for a second here. We're going to graph A. I'm going to do it in blue. Basically, if it's x squared and then not in parentheses, if it's a -6 or a +1 or something like this, tells us a shift up or down. So letter A is going to be a shift down 6 units. So 1, 2, 3, 4, 5, 6. So all of these are going to be shifted down 6 units. 1, 2, 3, 4, 5, 6. Right, so that would look something like that. And again, you could check on your calculator if you wanted to. Now similarly with letter B, I'll do in green, that's going to be a shift 1 up. So basically everything gets shifted 1 unit up. So it would look something like this. Right, now when the plus and minus a number is inside parentheses and then that all is squared, like in letters C and D, that actually shifts it left and right. Now, what is odd about this is that if it's a +3, it actually shifts the parabola 3 units to the left. So 1, 2, 3. You would expect it to be shifted to the right because positive goes that way, but these are kind of running opposite. So in any case, x plus 3, all in parentheses, then squared, would look something like this. And then this y equals in parentheses x minus 4, that squared, would actually shift the parabola 4 units to the right. So again, something like that. Alright, so with all that taken into account, we can try to do number 2, where it kind of combines these. So this would be, this part is a shift up or down, and then this is a shift left or right, and it's kind of left would actually be positive, right would be negative. It's kind of opposite what we normally think of when it comes to a number line. So this actually would be 1 unit right, and this would be 4 units down. So this part is kind of typical of what you think. You think positive going up, negative going down, and that's what this part does. The part on the inside of the parentheses kind of does the opposite. So what would this look like? You would take this turning point, this minimum, and shift it 1 unit right and 4 units down. 1, 2, 3, 4. And then all the other points we'd fill in kind of like that. So this one, letter A, I did in green. Right, so for this letter B, this would be a 1 unit down. And then this tells us 3 units, you would think to the right, but it's actually to the left. So 3 units left. This one I'll do in blue. 3 units left, 1, 2, 3, and 1 unit down. Right, and all of the points on that parabola do the exact same thing, so that one would look something like that. So just to kind of, so this letter A would have a minimum at 1, 1, 2, 3, 4, 1, -4. I know it doesn't, does it ask for that? I don't think it asks for that, but, and then this would have a minimum at -1, 2, 3, -1. So So, moving on, which of the following equations represents the graph shown? So we know that y equals x squared looks something like that. So this one, the turning point, is shifted, can you see that? Is shifted 1, 2, 3 to the right, 3 right, and 1, 2, 3, 4 down. So because it's shifted 4 down, we can eliminate 3 and 4 because these are telling us to shift 4 up. Alright, now 3 to the right, even though that's in the positive direction on the x-axis, it would actually be the minus 3. Okay, because again, when it's in parentheses, it kind of does opposite. So that's our answer, number 1. Alright, moving on. Alright, state the turning points for each of the following quadratic functions and state whether the parabola opens upwards or downwards. Remember, the direction is, I think you can say the direction it opens only depends on the leading coefficient. So, let's go through and just do upwards, downwards. So leading coefficient positive, so up, negative, down, down, up. Now this one, if we switch it around, we'd have to do negative x squared plus 9. If you want to see a little picture, here's 9, here's negative x squared. If we flip those around, we'd have to put the negative x squared and then plus 9. Don't confuse that with, some people might think it's x squared minus 9. It's a different picture, if you can follow that. So not that. Okay, in any case, so this would open down because it has a negative leading coefficient, and then this one would open down. Now if we go back through, I know it doesn't ask for that, but if it opens up, that means that the turning point is a minimum. If it opens down, it means it has a maximum. So all of these downs have a max, all of the ups have a minimum. Now they're all turning points, but some are maxes, some are mins. Okay, now let's go through and state the turning point. So this is where we're going to use, I think this one was this piece and this piece. So the turning point for this one, this is going to shift it 7 units up. This is going to shift it 2 units to the right. So this is telling us that we go 2 units to the right on the x-axis and then 7 up on the y-axis. So its turning point is at 2, 7. So this one, we'd go 4 up and 6 to the left. So to the left is negative on the x-axis, so negative 6, and then 4 up. For this one, this would be 4 to the left on the x, so negative 4, 3 down, negative 3. This would be 1 to the left, so negative 1, 7 down, negative 7. Now I'm going to use this one right here. All right, there is nothing in parentheses, so that says don't go left or right. So that means our x value in the turning point would be 0, and this would be shifted 9 units up, so 0, 9. And then finally this last one, 5 units to the right, which would be positive 5, and 11 units up. Okay, moving on. An object traveling under an acceleration due to gravity alone will have a height h in meters above the ground t seconds after it was fired, given by this, negative 4.9, in parentheses t minus 6, all squared, plus 210. At what height does the object begin at t equals 0? Show work. Now the work that I'm going to show is on my calculator. I was already doing a little graphing. Alright, so what I'm going to do, I'm going to store 0 for x. I'm going to use x because our calculator, it has a t, but you got to use x for the variable. So negative 4.9 parentheses, x minus 6 squared plus 210. Make sure you type that in right. If you put the exponent in the wrong spot, you're going to get the wrong answer. 33.6. Now that means that this was fired at 33.6 feet above the ground. So maybe on a tower or something. Something like that. Letter B. What is the peak height this object reaches in meters? When does it reach this height in seconds? So we could do this on a calculator. So let's type in negative 4.9 x minus 6 squared plus 210. And let's look at a table. Now, it's going to be negative for quite some time. I think we have to go back. So you can see right here on our table, we can kind of see where the max would be. So this is asking what is the peak height? So it's going to be 210 feet. Now we could also get that just from the equation. Okay, that plus 210 means it's shifted up, or the turning point is shifted up to 210, so we would know that it's 210 on the y-axis. And then in here you could see the 6. That would be the x-axis to the right, which is time. So after 6 seconds, it will reach its maximum height of 210 feet. Although you should be able to answer part B without your calculator, provide evidence. Oh, we already did that. Boom, there it is. Using your calculator, sketch a graph of the height over the interval shown. So at 0, we said that it's going to be about 33.6 feet. At about 6 seconds, it's going to reach its max height of about 210. If we look at our table, after about 12 seconds, it goes from 33.6 feet to negative feet. So I don't think that's going to happen. So right around 12 to 13, it's going to hit the ground. So something like this. And no arrows because we can't go back in time, and we're not going to go below ground. Alright, last one. Why does the turning point of the quadratic y equals a, and then in parentheses x minus h, all of that squared, plus k, not depend on the value of a? In other words, why do both of those have turning points at 2, 3? The lead coefficient basically it does maybe one or two things. Number one, it tells whether it opens up or down. The other thing it does is, if you actually look at these, so that's whether they're positive or negative. If you start looking at the patterns, the bigger the leading coefficient is, the skinnier, I guess, I'll call it skinnier, wider or skinnier. Skinnier like this. I think I spelled that right. So if it's like a negative 8 is going to be skinnier than negative 5. Negative half is going to be wider than negative 1. Things like that, where it affects how wide it opens, I guess, is another way to say that. But it doesn't shift it, so that's something you could say for that. They both have the same turning point, but this one would open up down, this one would open upwards, this one would be a little skinnier than this one, but it doesn't shift it at all. Alright, well, hopefully everyone's doing alright. Hopefully that's a help. We'll see you soon.